Okay, Bismillahirrahmanirrahim. Assalamualaikum. My name is Nurin Ajana binti Rizman. My matrix number is 1203161. So today I would like to present to you guys about tutorial 4, which is thermodynamics, the second law, for question number 3. Okay, now let's see what is the question asked for. Okay, now let's read the equation first. The enthalpy of vaporization of chloroform CHCl3 is 29.4 kJ per mole at its normal boiling point of 334.88 Kelvin. Calculate the entropy of the vaporization of the chloroform at this temperature and the entropy change of the surroundings. We note that the information given is the delta H of chloroform, which is 29.4 kJ per mole, and also the temperature, which is 334.88 Kelvin. Okay, now let's proceed to the first question, which is the entropy of the vaporization of chloroform at this temperature. We already note that before the enthalpy for chloroform is already given, which is 29.4 kJ per mole, and the temperature is 334.88 Kelvin. So, as we learned before, the equation for the entropy of the vaporization is delta vap S equals to delta vap H over Tb, which delta vap S stand for entropy of vaporization, and delta vap H stand for enthalpy of vaporization, and Tb stand for temperature in Kelvin. Since we already have the information of delta H and the Tb, we just need to substitute the information given into the equation. So, the final result we got positive 87.79 joule per Kelvin per mole. Why in the final result we put this positive sign? Because since we know that this process is endothermic process, the final answer must have positive sign. Okay, now let's proceed to the last question, which is the entropy change of the surroundings. Same as before, we still use the same information, which is the delta H of chloroform and also the temperature. But the difference here is the equation. As we look at here, the equation for the entropy change of the surrounding is delta S sir equals to negative delta HC over T, which delta S sir stand for entropy change of the surrounding, and the delta HC stand for enthalpy of the system, and last T stand for temperature in Kelvin. So, since we already have the information given, we just need to substitute in the equation, which is the final result is negative 87.79 joule per Kelvin per mole. What the difference between this question and the previous question is the sign of the final answer. As before, we got the final answer as a positive sign, while for the last question, we got the final answer as the negative sign, because the energy already lost from the system as heat. That's why we use the negative sign. Okay, that's all from me. Thank you.